Hello, this is Ryan Woodward recording for Intel's Digital Logic course. This is Lab 1, Part 4. This is where we're building a basic binary coded decimal decoder. And this BCD decoder had to handle 4 instances where we print out the letter D, the lowercase d, uppercase E, then the value 1, 0, and then I added a default just in case. It's good practice to have that, but it doesn't actually do anything because there's only 2 switches, and for each switch we have an output assigned. So when both switches are low, we'll see a lowercase d. When switch 1 is high, we will see the letter E. When switch 0 is high, we will see the value 1. And when both switches are high, we will see a 0. And it's that simple. I just use a process statement to process the input C above in the ports here, 1 to 0. And then we have our H, this is for the hex display, 0 to 6, as there are 7 segments. And we process that, and we have a case statement when C is, according to these 2 values, it's that, we will assign that output to H. And similarly in Verilog, we have a very similar setup, where we have the input is C, 0 to 1, output register is 0 to 6 for our hex display. And then we have an always statement. That's one of the keywords to show a behavioral in Verilog, is that we see this always, but we have a similar case statement in C where we have 2-bit wide. We have these 2 values for our switches. So 2-bit wide 0, 0, 0, 1, 1, 0, 1, 1, and we will see respectively D, we will see E for the second, 1, then 0, and then there's just a default, just because that's good practice. Alright, but that's the code for this lab part. I will demo that. Alright, and here is the basic binary coded decimal decoder, BCD decoder. So we see when these 2 switches are low, we have D to the output. If we flip switch 1, we get E. If we flip switch 0, we get 1. And if we switch both high, we get 0. So what we're seeing is D, E, 10. Alright, and that's it.